5 Chapter 2 Differentiation 2.3 The second derivative. Consider this function f(x), y equals to cubic function power 3. First derivative dy dx. Okay, it become cubic function. And then derive again, it become d2y dx2. So this one we call second derivative. Or we are given fx, first derivative become f prime x, second derivative become f double prime. Differentiate the first derivative. Okay, recall back how to differentiate. Given y equals to ax power n, so we differentiate it with dy dx, and go in front, an multiply, and then x n minus 1. So differentiate ax power n equals to an x power n minus 1. For example, given y equals to 3x squared, then if you differentiate 3 times 2, 6. And then x, 2 power 1 become 1. Okay, next. Example 11. Find the dy dx or n d2y dx. So for this function, okay, let's see. Number A. Y equals to x power 3 plus 4x power negative 2. We move the power go to front, become negative, easier for us to do the differentiation. Okay, let's start. Dy dx equals to 3 go in front, 3 minus 1 become 2, plus minus minus 4, 2, 8, x power negative 2 minus 1, negative 3. So this is dy dx. d2y dx2 equals to 3, 2, 6x, 2 minus 1, 1, negative, negative, positive, 8, 3, 24, x, negative 3 minus 1, negative 4. Okay, but our final answer is better to put in the power in no more negative. We simplify this one. Okay, we copy down. This one, 8 over x power 3. So this is final answer. Same to d2y dx2. 6x and then plus 24 over x power 4. Okay, A, done. Okay, B, g double prime. So we have to differentiate. This one is gx. So we g prime, the first derivative for g function, 3 to 6x squared plus 3 to 6x minus 7. Okay, so this is the g function, but we want double prime, we want second derivative. Excuse me. So double prime, 6 to 12x plus 6, second derivative. Now this no more x, this one is the number, then we substitute the number into x. Using which function? Using the second derivative function, this function. We're using this function, second derivative. Okay, so just substitute the value inside, that's all. Okay, 4, 3, 3 plus 6, 9. For this one, same. So 12x plus 6, we are applying this function. There are three functions, gx, g prime x, g double prime x. So we are using the third function. And now we substitute the value inside. Negative 12 plus 6, negative 6. Done. Okay, example 12. Given function f, find the value of x. Okay, now the question asking you to find the value of x. You must know what the question wants. The question asking you to find the value of x. Okay, and given this condition, f prime equals to f double prime. What is it? So you need to find f prime, first derivative. You need to find second derivative. Then you equate the two functions, you equate. Okay, let's do f prime x equals to, from here, okay, this is f function, so 3x squared plus 4x plus 3. This is the first function. Then second derivative, derive it again. Normally I will write down vertically, easier for us to derive it. So 3 to 6x plus 4. So this is a first derivative function. This is a second derivative function. Given these two functions is equal. So now we equal the two functions. This is the condition given. Teacher, why you equal it? Because the given condition equal. So I follow equal. Okay, now when you see all in x in its equation, then we can simplify. 4x, the 6 go there, minus 6 become negative 2. 3 minus 4, negative 1. So this is a very familiar, the general equation for the quadratic equation. We can factorize it. 1, 1. So here negative, so negative 3 plus 1 become negative 2. Factorization. Now continue. So 3x plus 1 equals to 0, comma, x minus 1 equals to 0. This one all. So x equals to negative 1 over 3, x equals to 1. There are two values of x. Done. Okay, now let's see this question. Find dy dx and d2 by dx squared for this function. It is exactly same with example 11. So let's do again. dy dx 12x. Before we do this, it's easier for us to simplify the y. This one, you see the denominator here? So we make it y equals to 4x cubed plus 2x minus 5x power negative 1. Easier for us to differentiate. 12x squared plus 2 plus 5x negative 1 minus 1 negative 2. Okay, this is dy dx. Okay, now same with like just now, d2y dx I put here because here not enough space. d2y dx2. Okay, dy dx, this one. dy dx, I copy this one again. Okay, so dy dx 24x. This one 2 no more, and then plus minus minus 10 x power negative 2 minus 1 negative 3. Okay, so final answer we put it in simplified form 12x squared, okay, plus 2 plus 5 over x power 2. The power negative go down. This is final answer. Okay, this one also same final answer. d2y dx2 will be 24x, we copy down, minus 10 over x power 3. This one is our final answer. Okay, done. Okay, next example. Same with our example 12, we do it again. So g function. And now we want to find the first derivative. We see 1 prime, so it's first derivative. Second prime, second derivative. Okay, so now do g prime, meaning first derivative, 9x squared plus 4x minus 9. So now g, later we substitute the 4 inside, we get answer. Now second one, g double prime. G double prime means derive second time. I write like this, vertically, easier to differentiate. 9 to 18x plus 4. Okay, so now first find first derivative when the x equals to 4. So now we are finding when it is 4, we are using the function g prime function, and we substitute the 4 inside. Substitute the 4 inside, you take your calculator, you got the answer. Okay, same to this double prime, 18x plus 4, then double prime now negative 1, substitute value inside, and then you take calculator, you get answer negative 14. Done. Okay, let's see this question. If y equals to 5x minus 3, 5 dy dx, and then square it. B, find only d2y dx2, second derivative. So is it these two is the same? Because when you see, oh, this one I can square this. But actually, is it same or not? Let's try. Okay, y equals to 5x minus 3. dy dx equals to 5. Okay, now d2y dx square equals to 0. Okay, because it's constant. Now, the a, dy dx power 2. dy dx is 5. 5 power 2, 25. Done for A. B, d2y dx2 is 0. Okay, d2y dx2 equals to 0. Done. C, is these two answers same? No, it's not the same, right? So explain. Actually, this one we cannot square it. d2y dy d square, dy dx square, dy dx is your first function, you square it. It is not equals to the second derivative. Second derivative, we use the second function, we use the dy dx to derive it. It's not square the function. Okay? So done. Thank you.